Fantastic. So my name is David Klee. This is all things SQL in the Microsoft Cloud. So first of all, I want to thank all of you for getting up early on a Saturday morning, taking time to spend with us. And if you're watching this on a recording afterwards, thank you for taking the time to learn. These topics are fantastic. It's critical with the data ecosystem the way it is and the way the cloud is evolving and becoming more prevalent. So my name is David Klee. I'm lucky enough to be a Microsoft Data Platform MVP and a VMware vExpert. I run Heraflux Technologies. I've got a weird sense of humor. I call myself the founder and chief technical exorcist. My contact info is up on the screen there. Okay. So if any of you have had anything to deal with SQL Server in the past, there's a number of options if and when your company is looking to go to the cloud. And I'm not telling you to go to the cloud. Cloud is a fantastic use case for a lot of different scenarios and use cases. It's not the only one out there. If we're looking at what's out there, I know this is the Azure Global Day. I personally pick the Azure platform because, quite frankly, I make my living around the SQL Server platform. Microsoft wrote it, and therefore I get all the bells and whistles sooner before some of the other cloud platforms do. I like that. I try to stay on the bleeding edge, and you get to use some of these cool features months and sometimes years before the other folks actually get them. Okay, traditionally, SQL Server has been a box product for forever. It's a database management solution. It's also got analytics, it's got reporting, it's got integration, it's got all kinds of good stuff. The fun part here is that Microsoft on the Azure platform did in fact launch a relational database service starting in about 2010. So it's been out there for quite some time. But there's a lot of options. There's a lot of buzzwords out there. What do we actually need? So if we're taking an on-prem solution right now and we want to lift this and move this to the cloud, you've got tons of options. You've got infrastructure as a service, you have platform as a service, you've got database as a service, you've got other as a services that don't make any sense. We've got tons of choices. The single hardest thing that you can do is find which one of these solutions actually works best for you. So what you have to do is really do a deep dive on what they actually are, what they mean, what they do, what they don't do, and figure out what are the requirements of the platform that I'm coming from, and which of the cloud platforms makes the most sense. So to start with, we're going to take a really good look at Azure SQL Database. Now this is database as a service, and quite frankly, it's just a database. It is fully compatible all the way up to SQL Server 2019 for the features that it offers. It is limited in that, quite frankly, we don't have to deal with an operating system. I don't know about you, I have been patching systems in the middle of the night for over 20 years, and I'm not that seasoned as an IT professional. I am done dealing with all this unnecessary stuff. So quite frankly, if you just need a database, this is a phenomenal solution. It's got tons of great use cases out there. It's easy to use because it's just a database. You don't have to set it up. You don't have to even worry about backing it up. It just works. It's great for quick development. It's really good for smaller databases or POCs or pilots. You need to spin something up quick and go explore it. It's great for DevOps. If you've got a scale out environment that's got lots of single tenant databases, this works incredibly well for that. There's a lot of pros to this stuff. You don't have to worry about an instance. You don't have to worry about the operating system. So literally, it just works. You have very straightforward HA and DR options. You have SLAs to work with. What you need to figure out is, are my requirements within the HA and DR options available to me in the cloud? And a lot of times they will be, not always, but a lot of times. Now, it is just a single database. So what happens if, let's say, I'm running an application out there that has two databases underneath and they talk to each other? Well, unfortunately, that doesn't work. You have no cross-database calls. You don't have a SQL agent, but quite frankly, you got Azure runbooks, and it's just a little bit of PowerShell. You can take whatever processor you're doing right now, convert them over to runbooks. It'll work just fine. It's just a little bit of elbow grease to go clean it up. You may have to make some code adjustments. If you routinely have cross-database calls, you might have to go have the application call multiple independent databases with different connection strings. If you're looking at instance level components or file system level components, or even have some legacy code that might be dealing with XP command shell or some of these other pieces that they're OS dependent, you may have to go retool that. Or quite frankly, if it's a third-party app, it just might not work. The migration strategy is what gets a little interesting here. Now, they also have a serverless option, which I'll mention, which is phenomenal, because why pay for this stuff when you're not using it? For example, a lot of these databases might be run, let's say, 8 to 5, Monday to Friday. If I don't want to deal with that and have to pay for the compute side on the weekends, what's great? The serverless option allows you to say, if this thing isn't used for an hour or a day or a certain number of minutes, then I can just turn it off. You still pay for the storage, but it works really, really well. You have a maximum of 16 virtual CPUs that you can use. Gives you a decent amount of RAM on there. Quite frankly, it's a pretty good option for not 24/7 databases. Saves you a little bit of money. Max size 1.5 terabytes. It works really well. Now, there's some challenges with those. You cannot do a traditional database backup and then restore it into a SQL database as a service. That's a challenge. You sometimes, the database may be small enough where you can just recreate the database schema and then use SSIS or some sort of a data pump to just push the data in there. And for smaller databases, that works. But if you have a lot of things with, foreign key dependencies, lots of tables, lots of objects, or frequently changing data, you may need to go to some other mechanism to get data in there. You can do a backpack import and export. So if you just want the schema, a DAC pack works great, and SQL Server Management Studio can do this. You can do a backpack that includes the schema, but it also grabs the data. And it basically just builds out insert statements for you. So you may have to watch foreign key dependencies and things like that. May have to turn off some constraints, maybe. But it's a solid way to do it. Azure Database Migration Service also works incredibly well. And this is something where if you have a large database, you can actually build this thing out, connect it in, let this thing continuously pump data from your source database to the destination. And when you're ready to cut over, just cut your application, at the front end so you're not changing any data, finish it sync, and then flip it over and you're good to go. So these massive databases that we work with all the time, I don't have to have, days and days and days of a cutover window. I may just need a handful of minutes, which is really cool. There's a link up here. It takes you to more information about it. It is fairly new. It's a really cool service. I would suggest that you go explore it. Now, my personal favorite about the cloud, disaster recovery. If you've ever had to do a DR drill on-prem, watch out. There's just a lot of moving pieces. People get cranky. You need a lot of coffee. It's not a lot of fun. DR in the cloud is one of the single biggest strong points that you've got. For example, I've got a CMS database here for a little tool that we built. And if I want to replicate it from the East Coast to the Central, it's literally add geo-replication, click on a map where you want it to go, hit OK to approve the charges, you're done. And that's it. And that's awesome. And if I want to go test it, I can go query on it because I have it readable. And it just works. It's just amazing. Now, I'm going to show you here, so I'll zoom in here. This is actually that particular machine that we're looking at. Now, if you're familiar with SQL Server at all, what don't we have? We don't have an agent. We don't have management objects in here, such as database mail, maintenance plans, things like that, or link servers, stuff like that. But if I just need a database, and check it out. I've got tables, I've got stored procedures, I've got data. It honestly just works, and it's a standard connection string, and it literally just works. There's nothing fancy about it. It's just a database. If I need to restore this thing, it'll actually show up as a database with a date and timestamp from our restoration in the same instance here. And then I can grab information out of there, move it over, tear it down, and it just works. It's really, really handy. Now, that was a database as a service. So what happens if my application has, some constructs in there that are dependent on things like CLR? or I need to send emails from here, or I have two databases that communicate with each other. Something like that might mean that you really can't really use a database as a service too well without substantial code changes. What if it's a third-party app? You may not be able to get in and make some of these changes, or your organization may not give you the time to do it. So Microsoft more recently introduced a SQL managed instance. And literally, it's a SQL server without an operating system. You don't have access to that layer. There's bound to be one there. But quite frankly, it's just an instance. So now I can have multiple databases on here. I have an agent. For things that are in there, you get extended events. You can now use a service broker, CDC, transactional replication. You get your agent back. So if you've got a ton of agent jobs, you don't have to worry about recreating anything. You've got database mail, query store. You get tons of really good options in here. And quite frankly, this is a really compelling offering. If you just need to be able to stand up a handful of databases, this might actually be a little cheaper in the long run as well. So it all comes down to what you need. Now, pros here, again, it's almost a full SQL Server instance, and that's really good. It's less change to go worry about. I can get stuff to the cloud quicker with less impact. You can actually do a full database restore. So you can back something up on-prem, copy it up to Azure Blob, do a restore from there, and then it just works. You do get the SQL agent. Your HA and DR options get better. Your HA options, there's a standard tier and business critical tier. Business critical is essentially an availability group. And what you end up with there is an improved SLA. Now, again, it all goes back to identifying what SLAs you actually need. So keep in mind there, you don't pay for more than what you need, but definitely don't shoot yourself in the foot. It gives you a faster possible migration time. Now, just any platform, there's pros and cons. It is less flexible than if you have an operating system and have a regular SQL server, but I don't know if that's a trade-off that's worth arguing about, partly because if I don't need that level of flexibility, then take it away and give me a better platform that I have to manage less. Some external dependencies don't want to work, as Polybase, some link servers, things like that. HA and DR options, you are limited to what they offer. Backups, if you want to take a backup off of this, becomes copy only. You can, like I said, you can do the backup and restore. You can recreate the schema. You can do what we did with the other. You can still use ADES, Azure Database Migration Service. It all works. The best part about this, though, is a native backup and restore. One thing to think about, this is a database engine plus agent only. You do not get SSRS. You do not get SQL Server Analytics services as well. SSIS is possible, but you do need to worry about Azure Data Factory in order to make this work. It's essentially an external integration engine. Works incredibly well, does require that you do some retooling with your processes, but most of the time, they're not that complex. You can get in there and do that. The agent limitations, not all job types exist. For example, XP command shell, firing external operating system basic commands. Well, if the OS is not accessible, you shouldn't be running that anyway. Like I said before, backup copies are manual or copy only. You get a 4 virtual core minimum, 80 vCore max. Quite frankly, if you're looking at machines bigger than this, we should talk because they become unwieldy at that point. And then we need to start looking at another service like Azure Hyperscale Database, or potentially looking at the database architecture itself to see what we can do to break these into more smaller atomic units of work. For storage, you get up to 8 terabytes of, quote, fast storage, or I can have 4 terabytes of, quote, super fast. And these are Azure's labels, not mine. I think it's kind of funny that they call them fast or super fast. But most of the time, what I really need is RAM and write speed, and both of these do perform quite well. To me, the business critical side, that's the availability group. That's where I've got greater recovery time. Now, limitations, you get 100 databases max, you don't get Polybase. Quite frankly, if you've got more than 100 databases on a managed instance, you could probably spread that thing out comfortably. Again, you may not be able to. You got to look at your architecture. but this is one limitation to talk through. You don't have an operating system level to worry about, but I claim that's not really a con. That's actually a good thing because now I don't have to maintain that. The biggest thing that I do want to talk through, application vendor support. This is a big one. This goes back to the business side. if an ISV fails to certify one of these platforms and you call them up for support, are they going to fail to support you, not because it's not going to work here, but because they don't understand it? It's something you need to take a good look at. A lot of times, these vendors are years behind supporting the new releases out there and the new different platforms. It's up to you if you want to go down that road or not. To me, it's worth pushing the envelope sometimes because these vendors need that, and not a lot of them are willing to work with you on this sort of thing. But consider this as part of your platform selection. One other interesting point, I can back up into this, but I can't restore from it onto a regular boxed SQL Server product. And that's because the SQL version of the database is generally a higher version than the box product because a lot of the active development for SQL Server is getting rolled into this platform. So something to think about there. It makes life a little more interesting. Now, if you need absolute flexibility or if the application support from the vendor isn't there, or any other reason with different dependencies, then you've still got the virtual machine layer, IaaS. So this basically means I'm just going to deploy a VM out there just like we did on-prem, slightly different levels of automation, but the core concept is identical. So I'm going to deploy a VM. I'm going to install SQL Server. You have the maximum possible flexibility. You can customize anything you need, just like we've always done. The migration strategy now, it's whatever you were doing before. So transaction log shipping, availability groups, maybe mirroring if you want to use a deprecated feature, or just back up and restore into it. There's tons of options. The biggest question is, what do you actually need? Do you need the ability to get to Windows or Linux? Do you need the ability to have a downgraded patch level for application vendor support? You still have to manage HA, you still have to manage DR, you have to manage backups. But if you need this flexibility, of course it's there. So the choice is, what do you actually need? And this is a really hard discussion because if we go down the wrong path up front, you might end up in a scenario where you kind of wish you went down a different path after having done a little more exploration. So figure out which one of these. Explore, play. I'm sure you've got some Azure credits lying around. Spin one of these up. Tinker with it. Try to break it. Throw a copy of your app up there and see what it does. Make sure that everything looks good before you move forward. Work with your infrastructure admins. And a lot of folks on here are infrastructure admins. So work with your DBAs. Work together because quite frankly, DBAs don't have a lot of system administration background, and sysadmin folks don't know the nuances of SQL Server, and both of those will get in the way of making the right decision here. So weigh your options carefully. Now, you pick the platform. Now we have to pick the scale. And this is an even bigger one, and there are a lot of misconceptions on here. Quite frankly, I want this Italian supercar. What if I just need a good minivan in order to actually go get the job done? It's one of those. If I'm just going to the grocery store once or twice a week, I want the Ferrari to go do it, but do I actually need it? Not really. And quite frankly, I don't want to have to pay for the maintenance on the Ferrari just to go get groceries. So I call this right sizing. Now, this was big on-prem. It's even bigger in the cloud. One of the claims from the cloud is you pay for consumption. And there are a lot of services where you do Azure Functions, load balancing, storage, network traffic, things like that you do. But other areas, you pay by allocation. And that's an interesting phenomenon. You pay by what you allocate and not actually what you consume. So we need to be really, really careful about allocating what you need. Now, this is a big thing right here. I mean, this particular SQL Server, Azure West, SQL Enterprise, 8-core, 56 gigs of RAM, pay as you go, that's $3,000 a month. Quite frankly, if you spin this up by accident and forget about it, that's a lot of money. and it's just sitting there. It's literally a space heater. If you're not using the full capabilities of this thing, it's going to waste. We have to be real careful here. So I always ask, do you have a resource consumption baseline? And I know I harp about this in pretty much every presentation that I do, but it is absolutely vital that you do. Because if you don't, then whatever budget you're trying to save by going to cloud is going to be exhausted immediately, and then you're going to be in the negative there. That's not good. So what do you actually need? What kind of CPU? How many cores? How much RAM do you actually need? How much storage space do you need, including room for future growth? And most importantly, outside of CPU, how much speed of storage do you actually need? You get more flexibility and choice as you approach the virtual machine layer. But if we can identify what we're actually consuming right now, then the choice of the scale of the platform in the cloud becomes a whole lot easier. You have to define this. The telemetry that most system administrators have from a VM perspective on-prem are inaccurate when it comes to SQL Server metrics that matter. So I always ask, do you have a baseline? Now, some third-party tools can do an okay job with this. Sometimes we may not have the luxury of the budget to afford some of these tools. Low granularity averages with anything are just not accurate enough. I mean, an example of this, customer called up a while back. They were freaking out. Everything was running slow. They were blaming the network. And they said, my CPU consumption is only at 6%. My memory thrash isn't bad. We're not paging, so it's got to be the network. It's like, where'd you come up with that? And they were just guessing and pointing a finger. I remoted in the machine and opened the task manager. They had 32 CPUs, and literally 2 were peaked and everything else was quiet. The granularity that they had said 6% busy, but 2 were maxed out and found somebody had monkeyed with the setting in SQL Server to change CPU affinity. It was using the first 2 cores, everything else was idle. Very straightforward, easy to detect if you have the granularity there. So we need to go get this. So if you've got a third-party utility that can do this, fantastic. But I claim, let's go get the raw data and let's use the tools that we're most familiar with to help us figure out what we actually need. Windows Perfmon, you've got it. It's free. It works. We've got a how-to guide out here at this link. There's no contact info required, so I'm happy to put it in here. It's just a PDF. Looks like this. It tells you exactly how we like to see Windows Perfmon set up. Now, we do this at a 30-second interval. To me, 30 seconds is a good enough granularity to go see fluctuation in the machine. 5 or 15 or 30-minute granularity, you might actually lose some of the data that would actually help you figure out if something spiked from a job for 2 minutes right after midnight. You'd be able to see that. You wouldn't see it in some of the other telemetry. The instructions tell you how to make this thing cycle every night. It's not going to fill up the hard drive. It's an incredibly low amount of background activity. It's like 1% of one CPU core. It works really well. And it works. Now, if you wanted to, you could export all this to a CSV, use a relog command to go do it, review the trends in Excel. It's not the most fun. I claim that you can do better. There's a bunch of people out on the internet that always tell you to collect Perfmon data. Nobody tells you what to do with it. Well, we released something a while back that I have not blogged about yet. It's kind of quiet. It's a PowerShell script out of GitHub that allows you to convert a Perfmon BLG file and load it into a SQL Server database. So now all of the tooling that I like to use, so it could be SSRS, could be Power BI, it could be anything, could be T-SQL in Excel for presentation, could be whatever you want. I've got the raw data, and now I can actually get in and start to see what's going on here. So if I want to see the pulse of a SQL Server, here's an example of this. This is an 8-core SQL Server by CPU on a normal business day. And you can see that they had stuff kicking off right at midnight. They had something else run at 2 and then at 3, but it was 1 core in most of it being used. They were running some job about every half an hour in production. You can see right here when people actually went to lunch. You could see everybody pretty much got done working by about 4:30 in the afternoon. The place was cleared out by 5. And at 6 o'clock, they had a single threaded process run that took forever. You can start to get a good sense. Now, on an 8-core machine, where are they at with consumption steady state during business hours? I claim they're nowhere even close to 50%, and when during business time, and when they are, it's on one core. They're looking at moving this to the cloud. I claim that we could get away with either a VM or a managed instance at 4 cores and be perfectly fine. So we went in, we tested it, we confirmed it. Everything actually ran exactly the same in the cloud on 4 cores. They cut that cost in half. And sorry, Microsoft, if you're listening, but you're going to end up with happier customers and financially better off folks if you've right-sized this stuff. Same kind of thing. I can start to see the spread of what the activity was. This was a percentile analysis. Same kind of data. You can go see min, average, and then percentile spreads in here to just what's my variation across the given day. And again, this thing barely peaked 50% during normal hours at the absolute most. I claim is perfectly fine. Now, memory consumption is the interesting thing here. You've got Perfmon information and just raw memory, like available memory, paging, stuff like that. But this is where the SQL Server level telemetry really goes to help you. SQL Server hides what it does from a CPU and a memory standpoint from the operating system. So now with Perfmon, I can go get per instance level counters to grab things like the SQL Server buffer cache hit ratio or page life expectancy. Work with your DBAs to figure out what's good and what's not good, and put a lot of these metrics together to go see what we actually need. You might be surprised that you can get away with less than you thought and save that money. Storage operation, exactly the same. Now, a lot of companies out there, storage companies will tell, we can do 1 million IOPS. It's like, that's fine. But it goes back to that whole Ferrari versus minivan thing. The Ferrari might be able to do 200 miles an hour, but you're not doing that on a normal road ever, at least you shouldn't be. If I'm only doing 0 to 60 or 70 on the freeway here, you don't need something that can do 200. Same thing here. If my consumption in this case is 8 to 900 IOPS during those 2 nightly batch maintenance cycles, and then my reads never top a couple of hundred IOPS during the day, and then stuff ramps up a little bit in the evenings. Same thing with writes. It's just a good steady stream of data, but nothing crazy. Now I can go gauge, what do I actually need in the cloud? Every one of the cloud services are going to give you metrics around storage performance. With the VM, you can do this at a disk perspective. With managed instance, you get so many IOPS, so much throughput. You can figure this stuff out. Single drives on an Azure VM, and any cloud provider, have IOP and throughput limits. If I find that maybe I need 100 gigs, but I need 5,000 IOPS, it might be kind of interesting because the individual scale have different metrics that are available to them. These are the different ceilings on here. So the one highlighted here, 0.5 terabyte drive, you get 2,300 IOPS and or 150 megabytes a second ceilings on there, whichever is lower. Again, it's cheap, but like that, the thing before, if I need 5,000 IOPS but only 100 gigs, you might get stuck provisioning a bigger disk in order to go get the added speed. You got to be careful with this one, but this is where knowing what you need up front will really go help you. You get less choice as you go more towards the as a service side. With the VMs, you can bundle smaller disks together with Windows storage spaces and go bundle these things together, build one bigger drive that's faster with a smaller footprint. Do some testing there, make sure it works the way you want it to, make sure you want to keep things simple. You have options, but understanding what you need will help you sift through these different areas of the design. And then, quite frankly, it's not just SQL Server. Azure, you have Azure SQL Database, you've got Postgres, you've got MySQL and Maria. There's Cosmos DB if you've never played with this before. Cosmos is a great NoSQL offering out there. It can help you emulate a lot of different kinds of commands out there. There's Azure Data Lake. There's data factories for integration. There's some really good information out there. So now I'm going to jump back to the SQL Server out here, and I want to show you just some of the basics on here. Again, it's just a database, nothing too fancy out here. So I'm going to zoom in here, as you can see. So if I go pull database properties, you can see, it's a SQL Server 2019. All the normal stuff is on here. Query optimizer fixes. I can use a legacy cardinality estimator. I've got snapshot isolation turned on. There is an interesting thing around scale. You can actually see the scale here, and you can see This is a basic database. It means basically it's a whopping $5 a month. I get 2 gigs. It's kind of like their version of SQL Express. You're going to laugh, but I put my content management system out here when I was first developing it, just quite frankly, to see how bad it would actually run. It ran so well, I left it there. I didn't need anything more than that. I've got a couple of queries that run about a second. Not a big deal. You can see they compress everything. My space consumption is actually incredibly light. That's 5 years worth of time tracking tasks, things like that. I'm using about 30 megabytes. It's tiny. It's highly normalized, but it works. You do get some change tracking. Query store is turned on. You can actually see a lot of this stuff. I mean, it's just a database. If I look at the instance level properties, can't really see it from here. There's a handful of dynamic management views that are missing off of a regular SQL server, but it really does just work. If I want to take a look at a regular SQL server in the cloud, it's just a SQL server. There's nothing fancy about it. To me, all this works really, really well. So your mileage may vary, but take a really good look at what you actually need. You have to figure out the platform. You have to determine the resource allocation and scale. And I cannot stress this enough. Saving your company money truly makes you a hero. That frees up resources. It not only gets the eye and the attention of the CIO, but it gets the ear of the CFO as well. That gets you training budget. Hopefully it might actually get you a raise. It makes you look really good. It helps you do your job, and they're going to be more likely to let you do that down the road. You get tons of platform choices. Their database as a service, instance as a service, VM as a service, or stay on-prem. It's up to you. Pay by allocation is the thing that trips most people up with the cloud. So that right-sizing methodology is phenomenal. Ping me at any time if anybody has any questions. I can help you set up Perfmon. I can take a quick look at it for you. It really does matter. Leave enough headroom for growth, of course, because there are sometimes outages for resizing these things. But don't shoot yourself in the foot with any of this stuff. But it works. Scale it as needed. Okay. So officially, we're going to do questions at the 12:30 Q&A session. Thank you all for attending.